Welcome to another lesson where we are going to take chi-square analysis and try to explain it simply and easily for everybody to understand. Now, before you be able to move on to this lesson, you have to go back to our previous lesson where we talked about the types of data. So once you are done with that, then we can move on to this lesson. Okay, let's get into it. Now, in the context of data analysis, the chi-square test is represented by the symbol x squared, s squared. The chi-square test is basically a statistical test used to determine whether there's an association between categorical variables. So if you have two categorical variables, for example, gender and then cancer type, and we want to know if there's an association between these two variables, we can use the chi-square test to determine whether there's an association. The chi-square test works by comparing observed frequencies with expected frequencies. Now, what do I mean by observed frequencies? Observed frequencies are the real numbers or the actual counts from your data. For example, assuming maybe in your final year project or in your research, you do a survey and then you want to know the number of smokers with lung disease and then the number of non-smokers with or without lung disease. So in your data, you were able to get 30 smokers with the disease, 20 smokers without the disease, 10 non-smokers with the disease, and then 40 non-smokers without the disease. So the frequencies here, that is the 30, 20, 10, and 40, becomes your observed frequencies because that is what you actually observed or you actually took when you were taking your data. The expected frequencies, however, is what we would expect if smoking and then the risk of getting the disease had no relationship. To put it in another way, the expected frequencies will be the numbers that we would expect if the chances of you smoking is not related to getting lung disease. So assuming you smoked and you got the lung disease, then we can say that the chances just happened out of coincidence. Okay, so in SPSS, we can simply cross two categorical variables to be able to get an expected value. And then that expected value will help us know whether there's a relationship between the two categorical values. So how can we do this? Now, the expected value E is given by this formula. The row divided by the rows, times the column, all divided by the grand total. For example, in our previous data that we have collected here, the total row will be 50 by the total column, which is 40, divided by the grand total, that's 100. And then the resultant value will become 20. So what does this imply? This means that if smoking and the risk of getting lung disease were unrelated, then we'll expect that 20 smokers will get the disease and not 30 from data that we collected. So if smoking and lung disease were not related to each other, then we will not get this 30 smokers with the disease, but rather we'll get 20. So this is what the chi-square test simply tries to achieve. Good. Moving on. The key points that we have to know about the chi-square test is that chi-square test is mostly run for categorical data. Examples of categorical data would include gender, number of responses, disease type, and so on and so forth. 2, the data must be in counts or frequencies. The data must be in counts or frequencies and not percentages or continuous values. Good. Now, the formula for the chi-square test is given by what is represented here. But the SPSS software can automatically generate the chi-square for you and then the expected value for you. But it's also good to know the formula for the chi-square test and then the expected value test, which is represented in the data as you are seeing here. So this is the expected value, and then this is the formula for the chi-square. Now, so assuming you have run an analysis and then you have gotten a chi-square value. Now, if the chi-square value is large, then it means that the observed data is different from the expected. So if the observed data is different from the expected, then there's likely a real association between our variables. However, the opposite is true. If the chi-square value is small, then the observed data is close to the expected. So we can safely say that there's no evidence of association. There's no evidence of association. Now, most of the time, you wouldn't be demanded to manually calculate the chi-square value and expected values, especially when you are doing your own research or in your final year exam. The chi-square value can be obtained in SPSS automatically. All you have to do is to do a simple descriptive and run a cross tabulation between two categorical variables. And then SPSS will automatically generate the chi-square value for you. Now, in SPSS, after the chi-square value has been generated, you are also going to see other values being generated. These values would include the p-value and the degree of freedom. So for example, this is a cross tabulation between gender and then the number of people who own a car. So in this example, we can see the expected counts here and then the observed values here. And then in the second table, we see that the chi-square value, which is the Pearson chi-square value, has been calculated here. We are getting our degree of freedom and then our p-value here also calculated for us automatically. We are going to soon see how we'll be able to input this in our chi-square in SPSS shortly. Moving on. Now, after SPSS has been able to generate your chi-square table for you, the next question will be, how will I know if the chi-square value is large or not? Now, in order for you to know whether the chi-square value is large or not, you will have to check your p-value from your chi-square, and this is representing the p-value. You have to check your p-value. Now, if the p-value is less than 0.05, then it means that your chi-square value was large enough, and hence there's a real association between the variables. However, if the p-value is greater than 0.05, then it means that your chi-square value was small, and hence there's no association between the variables. So your SPSS output after your cross tabulation is going to give you your chi-square value, the degree of freedom, and then the p-value. So as I said earlier, if the p-value is less than 0.05, then it means that there's no, then it means that there is a significant relationship between, for example, in a scenario, smoking and having a disease, meaning that there's a real association. If the p-value, however, is greater than 0.05, then it means that there's no significant relationship. Hence, there's no association between the two variables. Good. Moving on. In our example, chi-square value was 20, right? So our degree of freedom, let's say, is 1, and our p-value is less than what? 0.01. And hence, we say that because the p-value is less than 0.05, there is a significant association between smoking and lung disease. And hence, smokers are more likely to have lung disease. So this is the whole point of running. This is the whole point of running your chi-square test, because we want to see if there's a significant association between two variables, in this scenario, smoking and lung disease. So in our example, because our p-value was less than 0.01, we will say that there's a significant association, and hence, the more you smoke, the more likely you are going to have a lung disease. Very simple, very easy. Good. Now, there are some common chi-square tests that we can run depending on the type of data we have. So let's dive into it. The first common chi-square test that we can run is the chi-square goodness of fit test. The chi-square goodness of fit test. Now, what does the chi-square goodness of fit test do? The chi-square goodness of fit test is going to check if a single categorical variable matches with a theoretical distribution. For example, assuming we had a question or we had an inquiry and we wanted to know if the distribution of a categorical variable match what we are going to expect. For example, you ask 100 people if their favorite food is apple, banana, or orange. And then we observe that 50 people says their favorite is apple, and 30 said their favorite was banana, and then 20 said their favorite was orange. Now, we are expecting that, also our theory is that all of them are going to say that they all like the fruits equally. So we are expecting that all the people, all the 100 people that we asked are going to like the 3 fruits equally. That is our expectation, right? So we can run a chi-square goodness of fit to see if our expectation from this example is true or not. So the chi-square goodness of fit checks if the observed preferences differ significantly from the equal expectation. The chi-square goodness of fit checks if the observed preferences differ significantly from the equal expectation. So, when do we use chi-square goodness of fit? We use chi-square goodness of fit when we are trying to compare one variable with expected distributions. For example, here we are comparing, or we are trying to see whether the 100 people, in our example, equally likes the fruits that are being described, or there's a significant difference between that. Good. Another chi-square test that we can run is called the chi-square test of independence. The chi-square test of independence. Now, the chi-square test of independence will check if two categorical variables are related to each other. The chi-square test of independence will check if two categorical variables are related to each other. For example, in our previous survey we did, where we were checking the relationship between smoking and lung disease. So in that example, smoking is one categorical variable, and then lung disease is another categorical variable. So because we have two separate categorical variables, the chi-square test that we run for this is the chi-square test of independence. And that is represented by our contingency table here. Now, the chi-square test of independence is going to check whether smoking and then lung disease are associated. So, when do we use the chi-square of independence? We use the chi-square of independence when we are trying to test the relationship between two variables in one group. Very good. Moving on. The last example that will be mentioned here is the chi-square test of homogeneity. The chi-square test of homogeneity. Now, the chi-square test of homogeneity is going to compare distributions of categorical variables across different groups. So, for example, assuming we want to see if three schools, that is school A, B, and C, have the same proportion of students who want to do science, arts, or business. So, in our contingency table here, we have the school A, B, and C being crossed with science, arts, and business. And then the respected observations seen there. So, our chi-square test of homogeneity is going to check if the distribution of subject choices is the same across all the schools. So, we use the chi-square test of homogeneity if you are trying to compare distributions across groups. If you are trying to compare distributions across groups. So, a quick reminder. The chi-square test of goodness of fit is used when we are trying to compare one variable versus a theory. When you are trying to compare one variable with a theory. For example, when you are trying to compare whether a group of people all have a liking to a number of fruits. Also, another quick reminder, the chi-square test of independence is used when you are trying to compare two categorical variables in one group. For example, if you are trying to compare or see if there's an association between smokers, and lung disease. The rate at which smoking can cause lung disease. Then we use a chi-square test of independence. Another example, the third one is the chi-square test of homogeneity. And the chi-square test of homogeneity is used to compare one variable across multiple groups. For example, if you are trying to compare a proportion of students in 3 different schools, choosing a specific course in the school, then we use the chi-square test of homogeneity. So goodness of it is just one variable with a theory. Independence is 2 variables, comparing 2 variables in a group. And then homogeneity is 1 variable across multiple groups. Very simple, very easy. So this is a short summary of chi-square and then the chi-square tests that we can run in SPSS. Very simple, very easy. Next, we are going to look at examples of scenarios where we are going to use the chi-square test to run analysis, and also which specific test we are going to use for our analysis. See you in the next one.